All right, good morning. You're doing well. Good to see you. Let me make a couple of announcements here at the beginning. First of all, people have been asking me about what's going on in classroom as far as the grades go. So you may see something like the unit circle quiz, or I'm sorry, that the quiz for the vocabulary is missing. Don't worry about any of that. Okay, so all I'm doing is posting assignments and receiving assignments. I'm doing all the grading in Zangle. All right, so as far as grading goes, don't pay attention to anything in classroom. You want to pay attention to Zangle, and I'll be updating that. I'm not going to update it every day. It's too hard and I'm too busy. And so after I get a few assignments and absolutely a test, I will update Zangle. The assignments don't really affect the grade that much. And so I'm not going to be making enhancements like I did at school every day. So don't worry about grades on Classroom. You only want to look at Zangle. The second comment is for the unit circle quiz. It's actually not a quiz, but I do have to verify that you know what you're doing before we go on. So in other words, if you don't get 100% on that, the lesson 17.2 with the unit circle quiz, there's no point in going on. So you have to know how to do that. So you have to be able to get 100% on that. You have to understand the unit circle. All right, anybody want to ask me any questions before we get started here? All right, well, happy Thursday. So on Monday, I had started 17.2, and it was actually the second part because I had introduced it the day before that on a Friday. But I want to make sure Max asked something and I kind of rushed through it, and I want to make sure you all understand this. This is very critical that you understand this. So see if I can get my board set up. Okay, I don't see any faces right now. So if somebody could possibly show your face and tell me if the boards are okay, or let me know if the boards aren't okay. Once again, it'd be great to see you. I'm talking to a blank screen right now. I see you at the bottom of my screen, but I don't see any faces, and it is hard on me to not see anyone because I can't get any affirmation when I ask you something and yes, you see it, no, you don't. And I'm just hoping for the best, which is, I feel like if you can see me, I should be able to see you, to a certain degree. So if you could let me know, that'd be great. Anyhow, so what I showed is when I showed the unit circle, I showed three graphs superimposed on each other. So for example, this one angle that I showed here, which was the pi divided into 6 equal parts, was pi over 6 or 30 degrees. And with that angle is a point that's associated to the angle. And that point, I showed you how to get it with your hands, or you can memorize it, I don't care, is radical 3 over 2 and 1/2. So you can think of that as xy, or you can think of it as, in trigonometry, cosine of theta and sine of theta. In other words, the value that is associated to cosine of the angle theta is square root of 3 over 2. And the value that is associated to sine of theta, the angle, is 1/2. Okay, now with that, what I was trying to get across last week is that you want to memorize these reference angles. And a reference angle, remember, is a positive acute in the first quadrant only. It's not negative, it's positive. and it is acute angle, which means it's between 0 and 90 degrees or pi over 2 radians. So this is one of the things I want to get across right here. This is important, you know. So this angle over here, which looks similar to that one, and this angle, and I am talking about these angles. You can take them the other way, you can take them this way, you can take them over this way. Any of those angles that you come up with, the points are the same as that reference angle. So in other words, all of those angles, however you want to make them, are square root of 3 over 2 and 1/2. Square root of 3 over 2 and 1/2. Square root of 3 over 2 and 1/2. So in other words, by knowing that reference angle, you don't have to memorize the other three. We already know what they are. The only difference is the quadrant and where they're located. So in this quadrant, your cosine would be negative and your sine would be positive. In this quadrant, your cosine of theta is negative and your sine of theta is negative. And in this quadrant, your cosine of theta would be positive and your sine of theta would be negative. So this is absolutely critical that you know this. And so what I'm saying is that you just need to memorize the reference angles. You can derive the other angles by just using the reference angles. So I don't know if you can see this, but I'm going to try another color. So if you didn't get that, let me try it again. I showed a graph divided into 3 parts. And that makes this pi over 3 or 60 degrees. And the point associated to that angle, right there, is 1/2 and square root of 3 over 2. And I showed you how to get this angle looking at your hand. So if you look at your ring, you can pull down this finger, and that's how you get 1/2 and square root of 3 over 2. All right, so anyhow, if you know that, you can come over to the second quadrant and go, okay, well, if I have an angle that looks like that, and the third quadrant, if I have an angle that looks like that, and if I have an angle that looks like that, they take on the same ordered pairs. So this ordered pair, whether you draw the angle like that, whether you draw the angle like that, it doesn't matter how you go around 500 times. The ordered pair would be 1/2 radical 3 over 2. And this point would be 1/2 and radical 3 over 2. And this point would be 1/2 and radical 3 over 2. So the only difference is the signs. So this would be positive, positive. This would be negative, positive. This would be negative, negative. And this would be positive, negative. And there you go. So if I asked you, what's the cosine of 60 degrees, you would say 1/2. If I said, well, what's the cosine of 2 pi over 3? You would say negative 1/2. And this would be 4 pi over 3, because this is 3 pi over 3. If I asked you what is the cosine of 4 pi over 3, you would tell me negative 1/2. That would be 5 pi over 3, because this is 6 pi over 3 over here. If I asked you what is the cosine of 5 pi over 3, you would tell me 1/2. Okay, so this is super critical. So can you, some of you unmute yourself and tell me, did this help, or you already knew this, or I made this clear? Because I just want to know for next time when I teach this lesson, was this clear the first time, or is it more clear now? So can you do me a favor, and I don't have to see you, but can you just unmute yourself? Just unmute yourself and say if this was helpful, or you already knew this and I wasted time. I hear from like 3 to 5 of you, please? Okay, good. Anybody else?
It was more clear this time. Wow.
Okay, good. All right, one more person. One more person, please.
I thought it was helpful too.
Okay, all right, good. All right, thank you. Okay, so I'm glad I did that then. So that was worth the time. So I really want to do an exercise with you, and this is the perfect time to do it. But I do want to get through this lesson. So I'm contemplating, should I do this exercise with you right now? Because I know it's going to be beneficial to you. Or should I try to finish the lesson? I think I'm going to do the exercise with you. Not going to worry, because I think that this is just more important, that I do this with you. So, all right, get a piece of paper. Make sure you have paper and a pencil. This is going to be more interactive. And I'll just be honest with you. One of the things that's really bothering me about this distance learning is that I can't be with you, because when I'm with you, I'm constantly checking you. So I'm constantly walking around and I'm looking to see, are you doing the problems right? When we get up on the boards, I'm checking your work. So I'm constantly seeing, are they okay? Are they okay? Are they okay? Do I need to repeat something? And so that's the one thing that I need to figure out with this distance learning is how can I check you to make sure you're okay? Because it might just be a little thing that you're messing up on. I can just say, okay, well, you just need to do this, and then everything's fixed. Or you have everything right except for this one little thing over here. And so most of the time, it's not like somebody's just really messed up. It's more like, oh, there's just a little thing here, a little thing there. And then we just iron it out, and then everything's okay. Well, I'm not able to iron out those little things. So it is frustrating because I just can't look at your work like I normally do. All right. So that unit circle quiz that isn't a quiz, I need you to do it after we do this exercise. I need you to do it anytime before 12 o'clock tomorrow. So I need you to do it and submit it to me anytime so I can start looking at them before 12 p.m. tomorrow. Okay, now, one of my students sent a message saying, do you want this done on Cami, or do you want us to send in scratch paper? And I said, I don't know. I have no idea. What do you think? And she said, you know what? I think it would be better just for everybody and for you if you just send it in on scratch paper. Okay, so just do it on scratch paper and give it to me. All right. If any of you disagree with that, then we can discuss it, but just put it on scratch paper and send it to me. All right, you ready? Now, when I was showing you how to evaluate the other day, I didn't go in to tangent, cotangent, and secant. So I didn't do any of those things. The reason why is because this little thing that I'm calling a quiz, I took from the trigonometry class, the pre-cal class. And so I want to explain that first. So here we go. So you have sine of theta equaling y. And you have cosine of theta equaling x. And you want to memorize them this way, by the way. So there's a reason why you're memorizing this way. So make sure you memorize them this way. This is one reason. Tangent is y over x. So that means those ordered pairs that I just had up on the board, that's how you're computing these trig functions. This is how you're evaluating them. Okay, we're going to do some. Now, on the other side, sine's reciprocal is cosecant. And that's 1 over y. And cosine's reciprocal is secant. which is 1 over x. And cotangent is 1 over this, but do you realize when you take 1 over a fraction, it's just the reciprocal? So that's something you need to know. If you have 1 over 2/3, that's 3/2. If you have 1 over 1/2, that's 2. So basically, when you take 1 over a fraction, you get its reciprocal. So cotangent is just 1 over y over x, which is just the reciprocal. All right. So what you're going to want to do is put that in a box. You must know that. Okay, so for example, if I asked you, what is the sine of 60 degrees? That's the y value, right? And you can hold up your hand, and now you can look at the, but you got to memorize this. But what I would do, if you were taking a test or quiz, I would draw a picture of the reference angle. So at the top of my paper, if I have you do a test, what I would do is draw a little picture and just do this like I showed you on the unit circle quiz. And I would show everything. So I would show pi over 6, 30 degrees, and the ordered pair, square root of 3 over 2 and 1/2, pi over 4, 45 degrees, square root of 2 over 2, square root of 2 over 2, and pi over 3, 60 degrees, 1/2, and square root of 3 over 2. Because since this is brand new to you, you don't want to have to try to keep it in your memory. You just want to see it. So those would be those points. This would be 0 radians or 0 degrees. And remember, this point is right 1, 0. And this point right here would be pi over 2 radians, or 90 degrees, or 0 up 1. Can't mix those up now. This is right 1, 0, that's 0 up 1. People in my pre-cal class are constantly messing those up. Don't mess them up. Okay, so back over here, if you used your hand, what would be the sine of 60 degrees? It would be the y value, right? So it would be radical 3 over 2. Ready? I want you to answer now, please. So I want this to be interactive, and then we're going to do some problems. You're going to do some problems. What's the cosine of 30 degrees? Go ahead, I'm listening. Cosine of 30 degrees. Remember
Radical 3 over 2.
Yeah, radical 3 over 2, good. Hopefully you can see if I write down here. So we're just doing the easy ones first. Let's try the sine of 2 pi over 3. Now, remember what I had you do with the reference angles? I had you find the reference angle, which is pi over 3, right? And then I had you evaluate the reference angle, pi over 3, and then I had you put yourself in the correct quadrant. So the sine of pi over 3 is what? Radical 3 over 2? And what quadrant is 2 pi, or yeah, what quadrant is 2 pi over 3? 2 pi over 3 is in the second quadrant, and sine is positive. So we keep the same value. I don't know if you can see that or not. You guys see that? So remember, you're finding the reference angle, you're evaluating the reference angle, and then you're evaluating the real angle by putting yourself in the proper quadrant. Now, on this quiz, you don't have to think about this because I didn't put the angles in the other quadrant. So on this quiz, I only focused on the reference angles. But this is what you have to look forward to. You're going to have to evaluate sine of 13 pi over 6. You're going to have to evaluate sine of 24 pi over 13. So that's where this is going. It's going outside of the first quadrant. But we're not doing this right now because this quiz, which is not a quiz, is only focused on the reference angles. Starting simple. I'm going to erase this. All right. Now, you do have to worry. These are called these are the reciprocals of sine. So sine's reciprocal trig function is cosecant. Cosine reciprocal is secant. It's very important that you remember this, that sine goes with cosecant, cosine goes with secant, and tangent and cotangent are easy to remember. But it's critical that you remember that sine's reciprocal is cosecant. All right, so let's try a tangent one. And I'm only going to go there. I'm not going to go into another quadrant. I just wanted to show you where we are going. All right, so let's try tangent of 45 degrees. Well, isn't tangent y over x? So look over here. Oh, I'm sorry. Is that okay? Can you guys see the top of the screens? Okay. So what would tangent of 45 degrees be? Somebody tell me.
Root of 2 over 2, and then radical 2 over 2.
Yes. Good. And that's 1. Good job. That's exactly right. Okay, let's get a little bit harder now. Okay. Let's do one of the reciprocals. Okay. So what if I asked you for cosecant, for secant of 60 degrees? Well, here's what you're going to do. You're going to, as soon as you see secant, you're going to, because we don't really like working with the reciprocals. Okay, I don't work with the reciprocals normally. So I only work with sine, cosine, and tangent. So the minute I see that word, I think cosine. So if I think cosine, I just go, oh, it's reciprocal. So what is cosine of 60? 1/2, right? So wouldn't this be 1 divided by 1/2? And we were just talking about this. Isn't this just 2? Now I'm going to prove it to you. I'm going to show you the steps I'm skipping. Ready? What this means is 1 divided by 1/2. And 1 divided by 1/2 is 1 times the reciprocal, which is 2. So rather than doing all this work, I'm just telling you that when you have 1 divided by a fraction, it's just the reciprocal. But if you want to do all the work, go ahead. I don't know if you can finish tests or not, but just go ahead if you want. I'm going to do a couple more, then you're going to do some. All right, and we're going to see how that goes. I hope it goes well so I can share it with others. Oh, shoot. Okay, let's try cosecant of 0 degrees, 0 radians. So the first thing I think of when I see this word is sine. So what's the sine of 0? Isn't it 0? So don't we need to take the reciprocal? So what's this answer? What's 1 over 0? All right, I'll give you an easier problem. What's 0 over 1? What's 0 over any number except 0? 0. All right, so this is 0. So what is 1 over 0? Can you have a 0 in the denominator of a fraction? I mean, you've only heard me say this like about 1,000,000 times. All right? Can you have it? Undefined, right, thank you. You cannot have a 0 in the denominator of a fraction. That's never going to change in your entire life. I don't care what math class you're taking. If you're taking differential geometry in college, take topology, I don't care what you take. Can't have a 0 in the denominator of a fraction. All right, so here we go. Let's try another one. What about cotangent of pi over 3? No, let's not do pi over 3. Let's do pi over 2. Quadrantal. Well, you know, you're only going to memorize sine, cosine, and tangent because you know that sine goes with cosecant. Sine goes with cosecant. Cosine goes with what? Secant. And tangent goes with cotangent. So if tangent is y over x, what's cotangent? X over y, right? Okay, so look at pi over 2. What's x over y? Well, I'm listening. X over y.
0 over 1.
Right, and what's 0 over 1?
0.
Are you guys ready? And you got your paper? Okay, I would have this somewhere in front of you. And like I said, you want to memorize this. And if you ever feel shaky, you can either look at your hand or on an exam, just write this down really quick so that you can look at it. You're not, because initially like this, you're going to just know this. But right now, you might need, something to look at. All right, I'm going to leave that stuff up. I'm going to go across the board now. I'm just going to erase this and work problems on the side too. All right, you set? All right, I'm going to give you a problem and I'm going to give you some time to do it and we're going to see if everybody can do it. Okay, and then what I really want is anybody who wants to show your face, put on a baseball hat or do something. I want you to show me a thumbs up or a thumbs down, and we're gonna see if we get this or not. So anybody who's brave enough to show me your beautiful little face, or not even show me your beautiful little face, don't show me it, just pull the screen down and put your thumb up in the air so I can see it. All right, so I would love to see you though, but even if you don't want me to see you, pull the screen down and put thumbs up or thumbs down up in the air. You can't even see mine. All right, here we go. All right, you ready for this? Let's start with cosine of pi over 4 radians. Okay, so you're going to think, is cosine x or y? And then what is the answer? All right. And we're going to go faster and faster. Okay, so we're going to start out slow, then we're going to speed it up. All right, so somebody unmute yourself and tell me, what is the cosine of pi over 4 when you're evaluating the trig function?
Square root of 2 over 2.
Right. All right, now, give me a thumbs up if you got it right. So those of you who are showing me, give me a thumbs up if you got it right. All right, if you got it wrong, put thumbs down. Okay, still don't have a lot of you, so if I could just have you, let me see you, please. You look wonderful. Don't worry about your hairdo. Look at mine. I look at my nails. How do you like that? All right, so if anybody looks bad, it's me. You look better than I look, so. All right, so let me see those little faces. I got more people joining. I need a couple more. All right, here we go. Let's try another one. Okay, so you do the problem. What's the sine of 30 degrees? Notice I'm going back and forth with degrees and radians. Pretty soon we'll just be working with radians. So right now, just working with the reference angles. All right, somebody unmute yourself and tell me, what's the sine of 30?
1 over 2.
1/2? Okay, so basically what I'm asking is, what is the y value when the angle is sine of 30 degrees? And so you're telling me 1/2. Okay, that is correct. Let me see thumbs up. Good, let me see thumbs down. Nobody? Okay, good. All right, let's try another one. I'm gonna get harder and harder. We're gonna keep speeding it up here. Okay, so what do you think about the cotangent, or I'm not listening to that. Let's do the tangent. How about the tangent of pi over 3? Now, I haven't done one like this, so let's see what happens here. Now, on this one, I'm going to want to know what you wrote on the first step. So before you give me the answer, I'm going to want to know what you did on the very first step. Because this can't be done by just looking at X or Y. There's going to be some math here. All right. Who wants to tell me what you did on the very first step? Come on. We don't care if you're wrong. Unmute yourself and tell me, what'd you do on the very first step?
Radical 3 over 2 divided by over half. 1/2.
That is correct. Now, a minute ago, I showed you a little trick. I said, hey, if you have 1 over a fraction, it's just the reciprocal. I'm going to show you another one. So everybody look up here. Whenever you have 2 fractions with the same denominator, it's like they just drop off. So this answer is radical 3. And I'm going to prove it to you. Watch over here. What this means is radical 3 over 2 divided by 1/2. And what that means, remember when you divide, you have to change it to multiply and take the reciprocal. So what happens on all these types of problems, which you'll have a lot of them, is you can cross cancel and you get radical 3. So rather than doing all that work, when I look at this, I just say, hey, those fractions, it's a complex fraction, but they have the same denominator, so it just drops off. But if you have a brother or sister in middle school who are doing complex fractions or something, you can explain to them, hey, this is a good trick, but this is what we're actually doing. In division, you change it to multiply, you take the reciprocal, those 2s, or those 7s, or those 9s, or whatever they are, As long as they're the same, they're going to always cancel like this. All right? So a couple things I showed you to eliminate some more. All right. So I did that one for you. So I cheat. I'm going to give you another one now. So I'm going to give you another tangent. Ready? I must have all of you now. Good job. Okay, so how about tangent of 30 degrees? Okay, I'm going to ask for the first step, and then I'm going to ask for the next step, and we're not going to do all those steps in between. So I want the first step and the last step. While you're doing that, I'm going to erase this one. Okay, let's hear it. What did you write on the first step?
1/2 over radical 3 over 2.
Radical 3 over 2, yep. Just check it. Y over x, that is correct. All right. I lied, there's not 3 steps. What's the next step, somebody?
1 over radical 3.
That is correct. And you can't have that. Can't have a radical in the denominator fraction. So you're going to have to simplify. Good thing we know how to do it. You're going to have to do this a lot. It's going to be radical 3 over radical 9, which is 3. Remember when you have two of the same under a radical? So remember this? This can be combined into one radical, right? So the answer is 3. You guys remember that, right? Okay, who got that answer? Good. Good. Anybody else? All right. Do another one. Okay, now remember, when you see cotangent, you're thinking tangent, and you just have to take the reciprocal, right? All right. So you're not writing y over x, you're writing x over y. And then you're simplifying. Okay, who has the first step?
Radical 3 divided by 2 over 1/2.
Okay, let's check it. Yep. Okay. And somebody else? What's your final answer?
Radical 3.
Yep. Good job. All right, let's do some more. All right, let's go to cosecant of 5/2. So we're working on these reciprocal trig functions. So when you see cosecant, what are you thinking? Say it again.
Cosine?
Cosecant is sine. Yep. So you're thinking, oh, that's sine, sine. I'm going to take the reciprocal of sine. All right. What do you write?
One over one.
1 over 1. Okay. So your final answer is 1. Yeah? All right. You guys good? Lucy, are you okay? Yep, okay. All right, how about secant pi over 6? So secant of pi over 6. So when you see secant, you're thinking what?
Cosine.
Okay. So you're taking the reciprocal of cosine when the angle is pi over 6. So this time I'll see who got it right. This is a few steps, right? This isn't something you're going to do like in one step. Okay, so let's hear the first step. How did you write the reciprocal?
1 divided by 1 over 2.
1 divided by 1 over 2. Are you sure? Because isn't secant's reciprocal sine? Can I hear that
Plus
again,
3 over
please?
2.
Radical 3 over 2? Give me a thumbs up if you think that's right. Okay. Okay. Now, what do we say to do when you have 1 over a fraction?
Do the reciprocal.
Yep. And if you feel shaky about that, then just do the math, do the division. So you can't have that. So we have to rationalize the denominator. I hope you can see my screen. I can tilt it down. You get 2 radical 3 over 3. Okay, now give me a thumbs up if you got it right. Okay, good. Good job. Perfect. All right. Give me a thumbs up if you feel okay about this quiz. It's not a quiz. Okay, good. You're going to be able to do it? Yeah? Okay, good. All right, great. All right, good. And if you still feel shaky, you just want to work a bunch of problems. Okay? And I gave you plenty of those in your lesson. You could actually, okay, so let me tell you what happened. So Google Meets crashed because students were setting up meetings and there were major problems with Google Meets. So if you've been having trouble using Meets, they think they resolved it, but at 11 o'clock yesterday, it still was shaky. And if any of you are having trouble getting into WebEx, so hopefully you're not because you're here. But if you're having any technical difficulties, let me know because I have a direct number to Gracie Gutierrez, who's the IT person up there. So I'm just calling her, just direct. So let me know if you have any issues. I'm gonna erase all this. All right, well, that was really good. So I'm glad that I stopped for that. I probably won't finish the lesson, but that's okay. This is really important stuff. So. All right, so we did that. We looked at the we looked at evaluating trig functions using reference angles. In other words, we looked at other angles and other quadrants, which you're going to be responsible for. You're just not responsible for that on this paper that I'm going to be checking, that you're going to turn in. Different than your assignment. Okay, so we ended last time by looking at the calculator and putting things on the calculator. So one thing that sometimes confuses students with the trig is there's different definitions for the same thing. So for example, I just showed you that sine is equal to y, but now I'm going to show you that sine is equal to y over r. Because this sign is for the unit circle. And this sign is when the radius is not 1. So let's say the radius is 5. Let's say the radius is 10. So there's a bunch of different definitions. And there's more than this. But yeah, a lot of different definitions. Here's another one. Sine of theta is also equal to 1 over cosecant of theta. So I just mentioned this, right? That a sine's reciprocal is cosecant. Anyhow, so don't be alarmed if it's like, why do they have all these different definitions? They're used for different things. So there are different definitions. So, all right. So basically, the trigonometric ratios, the fractions, can be expanded to coordinates x, y of any point on a circle with the radius r. So, and this is with the center at the origin. I'm getting feedback from me. So if you have your microphone on, if you can turn it off. I'm not writing down all the information. If you want to look at it in the book. X can't be 0 because you can't have a 0 in the denominator. This is for any point on a circle with a radius r centered at the origin. All right, so here's yet some more definitions. And basically, write this down. Okay, so the x and y coordinates of any point on a circular arc of radius r and an angle theta, and it does have to be centered at the origin, is this. That ordered pair is equal to, remember on Monday, I said that it was cosine of theta and sine of theta. Well, now I'm changing it a little bit. It's r cosine theta when the radius is not 1, and r sine theta. So a little bit different. Okay, now theta could be in degrees or radians. So it doesn't have to be in radians like there's a formula that I showed you earlier. It doesn't have to be in radians. It could be in degrees or radians. Circle. Like I'm writing a book. Okay, so we want to find the value or an expression for the coordinate on a circle centered at 0, 0, and at an angle from the x-axis. So what they're going to do in this problem, those are the directions. So this would be in your book, okay? They're going to say the radius is not 1 now. If the radius was 1, this would still be cosine theta, sine theta, but the radius now is 6. And they're going to say the angle is 124 degrees. And then it's going to put a comma and put x coordinate. So they're like, what the heck does this mean? Okay, they're giving you the radius, they're giving you an angle in degrees, and they want you to find the x coordinate. Okay. So what? I'm going to put some notes over here, but that's not a reference angle. So we're going to want to find the reference angle. I'm probably only going to be able to work 1 or 2 of these. That's okay. I'll finish the next on Monday. I felt like what we did today was more important than finishing the lesson anyway, so it doesn't matter. All right, so back to this. So we want to find the reference angle. So here we go. So we find theta prime. And the way we're going to find the reference angle, remember, is to, well, let's think about where this is. So 124 is, this is 90 degrees, and this is 180 degrees, and 124 is over here somewhere. In fact, 120. Degrees from that, we don't know anything. 30 degrees, 45 degrees, 60 degrees. We don't know anything about 34 degrees. So if I want to find the reference angle, I'm going to go to the closest horizontal. So if I take 180 minus 124, I'm going to get a positive acute angle in the first quadrant. So remember, you can always go to horizontals and subtract to get a reference angle. So 180 minus 24, I think it's what, 56? We don't know anything about that. So this didn't help us. Now, if we did get 30 degrees, 45 degrees, or 60 degrees, then we would have done this problem differently. But this reference angle, we're going to have to use a calculator. So you're forced to use a calculator. Okay, so we don't know anything about this. Doesn't help. So what we're going to do is we're going to say, okay, well, forget that then. We have r cosine of theta we're just going to put the radius in, and we're going to put cosine of 124 degrees because we can't do it by hand. Now, if you can, you have to do it by hand. So in pre-calculus, you have to do things by hand when you can. This we can't. So you're going to put it in the calculator. You're going to make sure your calculator is in degree mode. So go ahead and put this in the calculator and tell me what you get.
5.48127.
Can you try it again? Because what you're going to do is put cosine of 124, make sure your calculator's in degree mode, and then you're going to multiply by 6.
Is it negative?
It's negative.
Negative 3.35.
Yep. Negative 3.3. I think it's 6.
Yeah, rounds.
Thank you. Okay, so with this problem, we couldn't do it by hand and we couldn't find a reference angle. So when we come back on Monday, I'll show you a problem that we have to do by hand that we will be able to find a reference angle. But this is a very key thing right here. Another way to find a reference angle is to go to the closest horizontal. And that's what you saw me do. You saw me go to 180. And I don't care how you subtract. I don't care what combination or what you put first, but you must write a difference that gives you a positive acute angle in the first quadrant. So sometimes you might have to put 180 on that side. Sometimes you have to, make 124. Here I'm making it, minus 124. You just go to the closest horizontal and you subtract. Just make sure that it's going to work with whatever you do, get a positive acute angle in the first quadrant. Couple more notes and then I'll stop. Make sure your calculator is in the correct mode. In other words, if you're working with degrees in this problem, make sure your calculator is in degree mode. If we're working, this could have very easily been in radians. And if it's in radians and we can't find a reference angle, you have to use a calculator. You want to make sure you're in radian mode. And then here's the last thing I said. Write exact answers. In other words, don't use a calculator if possible. Now, in this problem is impossible. So now I'm telling you that if you can do something by hand, don't use the calculator, because in pre-cal, you're going to have to show the work. And so write exact answers if possible. Okay, I am going to stop there. Hang around with me if you want, but I'm going to turn off the recorder, and I hope you guys have a great day. Hope you have a good weekend. If you run into trouble, I'm available, all weekend, but you're going to have to let me know, okay, if you need help. So anyhow, you guys have a good day, and I'll see you later. And I'm going to turn off the recorder. But if you want to hang out, we can.